Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. So in the previous session we had finished the very first chapter of class 12th, that is relations and functions. So in this session we'll be doing some important examples of relations and functions. Alright, so relations and functions. In today's session, we'll be starting with important examples from NCERT. So before we start with today's session, students, so we'll just have a very quick recap of what are the relations we have studied. So we had studied relations and functions, right? So types of relations. Okay, the very first one, reflexive relation. Second one is symmetric relation. And the third one is transitive relation. So these are the three things, okay, which we'll be using in solving the problems. So what is reflexive relation? So A comma A belongs to R for all A belongs to set A. So if the set A has three elements, then A comma A, for all the elements of A comma A must belong to R, then we can call that relation as a reflexive relation. Symmetric relation, students, A comma B belongs to R, comma B comma A also belongs to R, then we can call that relation as what? A symmetric relation. And what is transitive relation? A comma B belongs to R, comma B comma C belongs to R. Then if A comma C also belongs to R, then we call that relation as what? A transitive relation. So what is relation again? Relations are nothing but set of ordered pairs. So that is also a subset of Cartesian product between two sets. So these are the types of relations which we have studied in the previous session. We have finished the synopsis. So this is just a recap. So this is reflexive relation, symmetric relation, then this is transitive relation. So we'll be starting with the examples today, alright. The very first example, so important examples. So whatever examples I'm going to present in this session, okay, all the examples are important. Okay, so the very first example, show that the relation R in the set. So set is given, A is equal to 1, 2, 3, let us take 1, comma 2, comma 3. So we'll start the solution from here. So this is the solution. Okay. So that the relation, show that the relation R in the set 1, 2, 3 given by R is equal to, so the relation is also given, students. So R is equal to 1, 1, comma 2, 2, comma 3, 3, comma 1, 2, 2, 3 is reflexive, so that we should show that the relation is reflexive, but neither symmetric nor transitive. So whatever relation is given here, R, so this we must show that it is reflexive, but it is not symmetric and transitive. So we have to prove that. Alright, so this is the very first example. So we should show that it is reflexive, correct? We'll write R here. So R is given by 1, 1, 2, 2, 3, 3. Okay, the next element is 1, 2 and 2, 3. 1, 2 and 2, 3. So this is the relation R. So now we should show that this relation R is reflexive, but this relation R is not symmetric and not transitive. So this is what we have to show here. Alright, so how to show that it is reflexive, students? So what is reflexive in the previous slide? If you see, A comma A belongs to R for all A belongs to A. Okay, see this one? A comma A belongs to R for all A belongs to A. So what is set A given here? 1, 2, 3. So do we have 1 comma 1? Yes. Do we have 2 comma 2? Yes. Do we have 3 comma 3? Yes. So all the elements, doublets we have here, correct? Image and pre-image are same of all the elements of A. So therefore what can we tell here? We can write that A comma A belongs to R. Therefore it is reflexive. Okay. So next, so this is the reflexive is done. Next, moving on to the next one, symmetric. So symmetric means, again moving back to the previous slide, A comma B belongs to R, B comma A also should be belonging to R. A comma B should also be inside R, B comma A also should be inside R. Then we can call that relation as what? Symmetric. So here if you take, so 1 comma 2 we have, correct? A comma B. Where is B comma A? B comma A is nothing but 2 comma 1. So 2 comma 1 is not defined in this relation. So therefore it is what? So here we can write A comma B belongs to R, but B comma A does not belong to R. So for example, we can take 1 comma 2. See, 1 comma 2 is belonging to R. It is nothing but A comma B. But 2 comma 1, is it there? 2 comma 1 is not given in this relation. So here we'll write 2 comma 1 is not belonging to R. Therefore, it is not symmetric. Okay. Next. So it is not symmetric, we proved. Next, it is not transitive as well. So transitive means what again? A comma B belongs to R, B comma C belongs to R, but A comma C also should be belonging to R. So if this condition is satisfying, then we can tell that the relationship is transitive. So here we'll take 1 comma 2 is belonging to R. So what is that 1 comma 2? A comma B, let us take A comma B is belonging to R, comma B comma C, that is nothing but 2 comma 3. B comma C is also belonging to R, then which implies A comma C also should be belonging to R. Then we can call it as what? Transitive relation. But 1 comma 3, is it belonging in R? It is not there. So here we can write with an example. 1 comma 2 belongs to R, comma 2 comma 3 belongs to R, comma, but 1 comma 3 does not belong to R. Correct. So therefore what we can tell? Here we can tell, therefore it is not transitive. Understood? So that is the reason. Okay, I had explained, or we had a very quick recap of these relations. So with the help of these, okay, you can solve the questions from examples as well as exercise problems for NCERT. So this is the answer for the very first example. So we have proved that it is reflexive, but it is not symmetric and also not transitive. Understood? So moving on to the next example, example number 2. So read the question here, students. All right. So here the question is, let R be the relation defined in the set A. So R is a relation defined in the set A, and A is given as 1, 2, 3, 4, 5, 6 and 7. So this is RA. Now see how is the relationship defined. R is equal to A comma B such that both A and B, okay, both A and B are either odd or even. This is very important point to be noted. Such that A and B are either odd or even. Show that R is an equivalence relation. So what is the meaning of equivalence relation, students? So whichever relation satisfies these three conditions, okay, if a relation satisfies reflexive relation, if a relation satisfies symmetric relation, and it also satisfies transitive relation, so together we call it as what? Equivalence relation. So equivalence relation means it should satisfy reflexive, symmetric as well as transitive. Understood? So here either odd or even, show that R is equivalence relation. Further show that all the elements of the subset 1, 3, 5, 7 are related to each other, and all the elements of the subset 2, 4, 6 are related to each other, but no elements of the subset 1, 3, 5, 7 is related to any elements of 2, 4, 6. I'll explain you what is that. Okay, so we are going to solve this question. So set A is given 1, 2, 3, 4, 5, 6, and we have to prove that the relation, how is it given? The relationship R is equal to A comma B such that both A and B, both A comma B are odd or even. So both A and B are odd or even. So this is the given relation. And what should we prove here, students? So what should we prove here? We have to show that given R, that R whatever I have written there, is an equivalence relation. Equivalence means what? It should be satisfying symmetric, transitive as well as reflexive. Okay. So now let us start with the very first one, reflexive relation. So this is the relationship given to us. Okay. So now let us start with reflexive here. So what is reflexive again? As we have seen earlier, A comma A should belong to R. Okay. So both A and B are odd or even. So whatever you take, so let A be equals 1, then 1 comma 1 belongs to R, 3 comma 3 belongs to R, 5 comma 5 belongs to R, as well as 7 comma 7 belongs to R. Okay, all are odds here. Even if you take 2 comma 2 belongs to R, 4 comma 4 belongs to R, 6 comma 6 belongs to R. So what we can tell here is the given relation R is reflexive. So in the place of A, sorry here student, in the place of A, any number you can take from this set. 1. So 1 comma 1, correct, because it is A comma A belongs to R. And what is A and A? Both are even or odd, correct? It is satisfying this as well. It is odd or it is even. So if you take 1, this condition will get satisfied. If you take 2, this condition will get satisfied. So therefore what we can tell, since A comma A belongs to R is reflexive, let A equals any element from set A, then it will be odd or even. Therefore the given relation is reflexive. Put a tick mark. Understood. Moving on to the next one. Symmetric. So symmetric relation. So symmetric relation means what again? A comma B belongs to R, then B comma A also should be belonging to R. If this occurs, then we can tell what? The given relation is symmetric. So but A comma B, what it should be? It should be either odd or even. So you can take any elements here. So 1 comma 3 if you take, then 3 comma 1 also will exist. Okay, 2 comma 4 if you take, 4 comma 2 also will exist. What you have to see here is, if you take 1 comma 3, both A and B are odd. Or if you take 2 comma 4, both A and B are even. So the given relation is getting satisfied, right? See this relation. This relation is getting satisfied. Both A and B are either odd or even. It is getting satisfied. So therefore we can tell what, students? See, both are odd here, both are even here. So therefore we can tell that the relation is symmetric. Understood. Next, what do we have? So reflexive is done, symmetric is done. Next we have transitive relation. So we'll write transitive relation. So what is transitive relation here? A comma B belongs to R, B comma C belongs to R, then if A comma C also belongs to R, then we call that relation as what? A transitive relation. So for example, if A and B, let us take it as 1 comma 3. Okay, both are odd. So we'll take the odd case first. Okay, B comma C, again we'll take odd case only. 3 comma 5 will take. Okay, 3 comma 5. Then what will be A comma C, students? See, this is A, B, B, C. Then what is A comma C? A comma C will become 1 comma 5. Both are either odd or even. Yes, it is odd there because we have taken set of odd numbers. Now suppose if you take even, so let us take 2 comma 4. Okay, and here you will take 4 comma 6. Then according to transitive relation it will become 2 comma 6. Okay, both what are they? They are even numbers. So they are telling either odd or even. You don't have any other choice. So here you see both are odd, both are even. So we can tell that the given relation is transitive. So once we have proved the given relation is reflexive, the given relation is symmetric, okay, and the given relation is transitive, we can call that the relation is equivalence relation. Understood? So we have proved that the given relation R, so this R, that is the given relation R. The given relation R is equivalence relation. Now there is another thing to prove. Okay, so that is related to it. So further show that, so from here student, the second part of the question, further show that all the elements of the subset 1, 3, 5, 7 are related to each other and all the elements of subset 2, 4, 6 are related to each other. So what is that each other here? So each other is nothing but the relations. So what are the relations we have proved here? Here we have proved reflexive, symmetric and transitive, right? We should show that 1, 3, 5, 7 is related to this as well as 2, 4, 6 is related to this, but we should also show that these both are not related to each other. Understood? So I think you have noted this down. I'll just clear the screen. Okay, we'll start proving the second part of the question. All right. So here 1357, let us take. So 1357, now try reflexive, symmetric and transitive. Okay, you will be getting A comma B will be odd, which is satisfying the relationship. Okay, similarly 246 also you take now. Okay, apply it for reflexive, symmetric and transitive. So here also we can tell A comma B will be even. So that is given here. So this is satisfying all the three relations. A comma B will be odd then. This is also satisfying all the three relations. A comma B will be even. Now if you take these both together, so that is given here, but no elements of the subset 1357 is related to any elements of subset 246, means take 1357, okay, and take 246. So if you take A from here, okay, and if you take B from here, so let us take for example 3 comma 6. Okay, they are not related to each other, we must show. And to show that, again we have to come here, A and B. Okay, so see there is one word here, both. Both A and B are either odd or even. Okay, here what is happening, if you take one element from this set and another element from this set, okay, both A and B are not either odd nor even. Okay, so this is becoming odd, this is becoming even. So therefore we can tell that, okay, so no elements, but no elements of the subset. So this subset and this subset cannot be related with each other. What is the reason, students? Because they will be both odd and even. Okay, it will not be either odd or even. So that is the reason. Okay, this is not related with each other, but 1357 is related to all the three. 246 is also related to all the three, but these both subsets are not related to each other. I hope you understood this. Any doubts, please do comment in the comment section. We'll be seeing that. Okay, moving on to the next question. Example number 3. So that the function, so here before we are doing relations, right? Now we started with functions. So that the function f such that n, what is n, students? Set of natural numbers, that's it. So n tends to n given by f of x is equal to 2x. So what is f of x here? F of x will be equal to 2x. Okay, that is what is given. F of x is 2x, is 1 1 but not on 2. Okay, we must prove that it is 1 1. Okay, 1 1 we must prove that, but it is not on 2. So we have to prove the, students. All right. So f of x is equal to 2x. First we'll how to start the proof for 1 1. So for 1 1 we have to directly take like this. F of x1 equals f of x2. Correct? Here we had x, so I have written x here. So the function is written as x. Now in the place of x we are writing what? x1. So in this place we must write 2x1 equals, here we'll write 2x2. This is 2x2. 2 and 2 will get cancelled. What are we getting? x1 equals x2. Therefore we can tell that the given function is 1 1. x1 equals x2, right? Images are same. Then the function also will be same, f of x. That is nothing but y. Y is equal to f of x. Okay. So we proved that the given function is 1 1. Now we should also prove that it is not on 2. Okay. So for on 2, how do we start the proof? Y is equal to f of x. Correct? Y is equal to f of x. Now what is f of x here? F of x is nothing but 2x. So y is equal to 2x. So what is x here, students, then? Send to that side. X will be equal to y by 2. Okay. Now when y is equal to 1, in the place of y if you put 1, what is x equal to? X will be equal to 1 by 2. Correct? If you put y is equal to 1, x will be equal to 1 by 2. But what do we know here? It is belonging to the set of natural numbers. And natural numbers begin from 1, 2, 3, 4 and it goes on like that. And we are getting x is equal to 1 by 2, which is not a natural number. Therefore we can tell the given function is not onto, but the given function is 1 1, the given function is not onto. So this is another example from the relations and functions. I hope you have understood this. Any doubts, please do comment in the comment section. Moving on to the next question. The very last question of this session. Okay, show that the function f such that r belongs to r. So what is r here? Real numbers again. Defined as f of x is equal to x square is neither 1 1 nor onto. So we should show that it is not 1 1. Okay, it is not 1 1. And it is also not 1 2. Okay, we have to prove this. So what is f of x given by? F of x is given by x square. So how do we start off for 1 1? For 1 1 we'll directly take f of x1 equals f of x2. So that will become x1 square equals x2 square. Correct? x1 square equals x2 square. So finally we can write x1 is equal to x2, or we can also write x1 equals minus x2. Correct? So now square on both the sides. So this one, if you square on both the sides, you'll be getting this one, right? Correct? So x1 square, x2 square. So this also you square on both the sides. x1 is equal to minus x2. So the square will give you x1 square, this square will give you x2 square only. But it is not equal to each other, right? So x1 is equal to x2 here, or x1 is also equal to minus x2. Therefore, what can we tell you, students? The given relation is not 1 1 function. Okay, so this is done. It is also not onto. So how do we take for onto here? So r is nothing but real numbers, remember that. Okay, set of real numbers. So for onto, what should we do here, students? So we will take y is equal to f of x. Correct? So what is f of x again? Y is equal to x square. Correct? Send the square that side. So x will be equal to root of y. Okay, and we are discussing about the real numbers here. Set of real numbers. So we will take y is equal to, let us take minus 7. So x will be equal to how much then? This is y is equal to x square. Yeah. Y is equal to minus 7 if we take root of minus 7. So this is what, students? Real numbers, and we are getting a root of minus 7. This means what it is? Imaginary numbers, or we can also call it as complex numbers. Okay, imaginary numbers we'll take. So this is an imaginary number, which means that it is not onto as well. Okay, it is not onto as well. I hope you have understood this. So we have done 4 important questions of class 12th NCERT today. Okay, so we'll be stopping the session here. I'll be seeing you in the next class. Thank you, students. Like the video if you have understood it, and also please kindly share and subscribe.